So very good evening students. I hope screen is visible to all of you and my voice is clear. Please confirm. Okay, so today's session we are going to discuss the topic that is capsule and microencapsulation. I hope you all have given the test. So let's solve it together and please let me know what are your answers. We are going to see in depth the explanation of each question. So I hope you all are ready. A very good evening all of you. So we'll start with the question and answer of this one. So the very first question that was asked in your GDC weekly test is, capsules are available in various sizes, that is 1, 2, 3, 4, 5, 000, 00 and 0 for human administration. Which of the following statements regarding capsule size is correct? So basically here they are asking that, of course, for hard gelatin capsule, because for soft gelatin 000, 00, these are not the sizes. So we have to identify P, Q, R, S. These statements are given and we have to identify among them which is the correct statement. So can you tell me which should be the answer for this? Okay, Ashish, Nurul, they are saying C. So let's see what is the option. First, what they are saying, 5 is the smallest capsule size. So yes, we know that among all these sizes, 5 is the smallest capsule size. 0 is the smallest capsule size, no. 1 is the largest capsule size, no. 000 is the largest capsule size. So ideally only P and S statements are correct. So option C is the right answer. Very good all of you. Yes, I hope everyone got that answer. Soparnika, Devi, Saurav, very good. So option C is the right answer. And the trick is that we have seen so many times in the class. Even if you remember 950, that's it. So just subtract 300, 200, 150 and afterwards you have to subtract 50, 50. So for example, 950 minus 300 you will get 650. 650 minus 200 you will get 450. Minus 150, 300. After that you have to subtract 50, 50. So you will get the weight in mg, so that to remember what is the capsule size and weight. Chalo, next question is, consider the following statements regarding type A and type B gelatin which is used in the capsule shell. So we have discussed based on the source of the gelatin, we have type A gelatin and type B gelatin. What should be the correct answer for this one? So let's see first of all the statement. Type A gelatin is obtained from acid treated collagen and it is having isoelectric point around pH 9. So we have seen iso means what? Iso means same, electric means charge. Isoelectric means which is having same charge. So definitely type A is the right answer. Statement 1 is the right answer because in case of type A gelatin, A is the acid treated, B is the base treated or alkali treated. The type A gelatin is having the isoelectric point in the basic region and type B gelatin is having isoelectric point in the acidic region. Okay, some are telling B, option B. Let's see. First option, statement first is the correct. Statement 2 is type B gelatin is obtained from alkali treated. This first part is correct. But the isoelectric point is not 7.4. Can you tell me what should be the isoelectric point? So basically for type B gelatin, isoelectric point is 4.7. Okay. So statement 2 is wrong. The main difference between type A and type B gelatin is the method of extraction and isoelectric point properties. So statement 1 and statement 3 are correct. So where is given statement 1 and statement 3? Very good. Option B is the right answer. All of you, I can see. Some of you have answered. Very good, all of you. Very good. 4.7 is the right answer. Yes, very good. So this was the second MCQ. The third MCQ is, so I think everybody knows the process of gelatin. We have seen so many times in the class also. The capsule grade gelatin typically exhibit Bloom values in the range of, we have seen what is the Bloom strength, how it is calculated, what is the instrument. The instrument is gelometer, right? So can you tell me what should be the ideal value? 50 to 100 gram, 100 to 150 gram, 150 to 250 or 300 to 400 grams. And we have also discussed the unit, right? We have also discussed the unit because when you are checking the bloom strength of the gelatin, you keep adding the weights, and because the weights that you are adding in the gelometer is in grams, the unit of bloom strength is in grams, that is 150 to 250 grams. Very good, all of you. I can see so many of you have answered the option C is the right answer. Very good. In depth I'll explain when we'll see this about the bloom strength. The next question is, according to quality standard, gelatin used for soft gelatin capsule should not contain iron more than dash. Okay. So we have seen that there are three important specifications of the gelatin. The first being the bloom strength of the gelatin, the second is the viscosity, and the third is the iron content of the gelatin. So iron is always present as the impurities in the gelatin because of the source of water. So according to the guidelines, what should be the minimum amount? Minimum as in maximum amount that should be present. So option C, I can see so many of you are telling 15 ppm is the right answer, that is 15 parts per million. That means a raw gelatin should not contain not more than 15 ppm, that is 15 parts per million. Very good, all of you. C, option C is the right answer. I hope everybody was able to solve. There was not a single question that we have not discussed in the class, right? So not more than 15 ppm is the right answer. The next is about the ingredient which is present, and in the class also we discussed that fumaric acid is something which will not be present in all the dosage form. So fumaric acid is added in the soft gelatin capsule shell 2. Can you tell me what should be the answer? Very good evening, all of you. So up to 1% increase capsule hardness. It is not about the hardness. First of all, it is about the soft gelatin capsule. It will not increase the hardness. Option B is up to 1%. Very good, all of you. I can see that you are answering option B. Very good, all of you. So up to 1% you should add because acid solubility and it reduces the aldehydic tanning of gelatin. With the time, there happens that the gelatin has the ability to undergo aldehydic tanning, because of which you can add the fumaric acid. And this is a very unique ingredient. So whenever you see any kind of specific ingredients which are present, you make sure that you highlight that one so that it will be easy for you to remember. Very good. Option B is the right answer. You should add up to 1% to reduce the aldehydic tanning of gelatin. So you can see fumaric acid. Rest of the things like same, the preservatives, parabens are there, vanillin is there. Then you can see titanium dioxide, which is opacifiers and all. But fumaric acid is something which is unique for this capsule. You're welcome, all of you. I'm glad that you are understanding at least. Chalo. And of course, you are also able to answer the question that tells that definitely you are studying. So MCQs give you the confidence, right? Whenever you are able to solve something, that gives you confidence, right? So don't miss the test, obviously. So next question is, in the manufacture of gelatin from bones, treatment of 5% HCl for 10 to 15 days is primarily intended to. Now whenever they talks about bones is made up of what? Calcium, right? So to reduce that or to dissolve this calcium so that it will not be present in the raw gelatin, we will decalcify. D means what? Removal of something. Decalcify the bone by dissolving the calcium salts, and this work is done by hydrochloride treatment. This work is done by hydrochloric acid. No, it will not be collagen fibers. When they talk about the bones, it is majorly made up of calcium, right? So calcium salts is the right answer. Very good. B is the right answer. See, bloom strength and all, that comes afterwards, right? Bloom strength depends upon the molecular weight of the gelatin, what is the cross-linking present them. So that I will discuss how it is calculated. So it is not about the bloom strength, and residual alkali also it is not there. Next is, all of the following statements about bloom or gel strength of the gelatin are correct except. First of all, bloom strength or the gelatin strength will tell you about the molecular weight. It is directly proportional to the molecular weight of the gelatin. Because if molecular weight is higher, the gelatin molecules are higher and definitely it will be more cross-linking between them. So gelatin tells you about the cross-linking between the gelatin molecules. Okay. So you take the gelatin, that is 6 into 2/3% of gelatin solution, keep it at 10 degrees Celsius. This is very important, 10 degrees Celsius for 17 hours. You will get a gelatin. Then you have to keep it for a 𝘿𝙄𝙎𝑚𝑒ter where a plunger diameter, the diameter of a plunger is 0.5 inches. You have to keep adding weights in the 𝘿𝙬meter until and unless this 0.5 inches diameter will go deep inside the whatever the gelatin is present. How much deep it should go? 4 mm deep. So these are very important points for the bloom strength. So see now what are the options. We have to identify which is the incorrect option because all of them are correct except option A is it measures the cohesive strength of cross-linking between gelatin molecule. Yes, it is about the cross-linking, whereas viscosity tells you about the molecular chain length. Okay. Very good. I think everybody can told me they have told about the D. I'll just see what is option B and C. It is directly proportional to molecular weight. Yes, because if molecular weight is higher, gelatin molecules are more, there will be more cross-linking, right? Cross-linking will be more and you will have higher bloom strength. It is measured using 𝘿𝙬meter. Yes. 𝘿𝙬meter also sometimes they call, and 300 to 150 is not there. This much high it is not there. We have already seen it is 150 to 250 gram. So this is a wrong statement. Rest of the three are correct. But option D is the right answer. Very good all of you. So see, this is a 𝘿𝙬meter where you will prepare a gel, right? So that gel has to be stored for 17 hours at 10 degrees Celsius and the concentration which you will use is 6 into 2/3% and 150 to 250 grams should be the ideal strength. Please remember units also. Sometimes they will ask you what is the unit of bloom strength. Okay. Similarly, you should know what is the unit of viscosity. Very good. Shall we go to the next question? So the bloom strength, just now I told you, the bloom strength test for gelatin measures the weight which is in grams required to depress a surface gel. Depress means what? This is a plunger, right? And here you kept your gelatin solution which is held at 10 degrees Celsius for 17 hours. They are telling required to depress a standard gel surface by 4 mm. That means this plunger will go deep inside. How much deep? 4 mm deep. What is the diameter of this plastic plunger? Just now I told you what is the diameter of this plastic plunger? 0.5 inch diameter. Option B is the right answer. Very good. So that has to be 0.5 inches diameter. Please remember this plastic plunger diameter is 0.5 inches. As you keep adding weights into the 𝘿𝙬meter, it will move down. How much down it should go? It should go 4 mm deep. And to move this, how much weight is required? That is nothing but your bloom strength. Okay. Very good. 0.5 inches diameter is the right answer. In the standard bloom test, the gelatin concentration used for preparing the test sample is, as I told you, in the viscosity you are using 6% of the solution, whereas in case of the bloom strength you have to use 6 into 2/3%. 6 into 2/3%. It is not 3/2, it is 2/3. What should be the answer? C. Very good. It should be 6 into 2/3%. That means 6 into 2/3 grams you will take if you are taking 100 ml of the solution. So you will mix that, it will dissolve and then you will use the solution. Whereas 6% you will use for the viscosity. 3% anyways it is not there. Okay. So very good, option C is the right answer. I hope till here everyone is with me. Any confusion in any of the questions? C is the right answer. Okay, very good. Chalo, the next is the bloom test for gelatin is performed at. Now they have been asking you what should be the condition, that is the temperature, and what for how much time you will held that gelatin. That is whatever 6 into 2/3% you will use. it should be held at what temperature and what for how much time? So can you tell me what should be the answer? Option A is 0 degrees Celsius for 12 hours. Option B is 25 degrees Celsius for 24 hours. Option C is 10 degrees Celsius for 17 hours. Or 37 degrees Celsius for 1 hour. Option C is the right answer. Very good. Okay, it is clear. Very good. 10 degrees Celsius for 17 hours. Very good. No confusion, right? Please. Sometimes they will give you opposite 17 degrees Celsius for 10 hours. No confusion. 10 degrees Celsius for 17 hours. Chalo, next question is, you are doing really well till now. We will see what are the next questions. The viscosity of gelatin, it is determined using 6% aqueous solution at 60 degrees Celsius primarily indicates. As I told you, for the viscosity, you will be using 6%, okay? And it is done at 60 degrees Celsius because at 60 only it will be liquid. How you will measure the viscosity, right? Once you take it back to the room temperature, it will get solidify and you will not be able to calculate the viscosity. So that is the reason 60 degrees Celsius. Now identify the correct statement. Measure of a molecular chain length and determines the manufacturing of gelatin. Option B is the Bloom strength. How the viscosity and the Bloom strength? No, Bloom strength is the another specification, viscosity is another. The concentration of plasticizer in the shell, it is not about the plasticizer. Plasticizer will give you either soft or hard gelatin, right? Increasing the concentration of plasticizer will give you soft gelatin, but it is not related to the viscosity. And the melting point of gelatin, that is not dependent on viscosity. So option A is the right answer. Always remember, viscosity is about the molecular chain length of the gelatin, whereas Bloom strength is about the cross-linking between the gelatin and the molecular weight of the gelatin. So option A is the right answer. I think till here it is clear. We will go towards the next question. Now the viscosity range for capsule grade gelatin generally lies between, as I told you, there is a specific unit, specific value that this much should be the viscosity of the gelatin. Because viscosity of the gelatin will ultimately tell you the thickness of the gelatin. If it is highly viscous, it will give very thick shell, right? And if it is having lower viscosity, it will give you lesser thickness. The capsule will not be proper. So 10 to 20 millipoise, 50 to 80, 90 to 120, it is very vast. 25 to 45 millipoise is the right answer, okay? 25 to 45 millipoise is the right answer. Very good. Option B is the right answer. These are very straightforward, like ideal value of gelatin viscosity, ideal value of Bloom strength, iron content of gelatin. Please make sure you write it somewhere if you will feel that I may forget till the exam, till the time of examination. Chalo. Next is, although gelatin capsule dominate the market, there is growing interest in non-gelatin capsule made from. So gelatin, you know, it is an animal source, right? But apart from gelatin also, there are some vegetarian capsule shell. We also call them as a vegetarian gelatin or vegetarian capsule or non-gelatin. So option A is starch, HPMC and pullulan, ethyl cellulose, shellac and polyethylene glycol, chitosan, sodium alginate and gelatin, polyethylene dextran and acacia. C will not be there because it is itself a gelatin, right? So option A is the right answer, which is also known as a vegetarian one. That is your starch. HPMC is your hydroxypropyl methyl cellulose. So these are nothing but the non-gelatin or vegetarian capsule shells. So everything that references and all, it is given in the Lachman book, you can see. Chalo, next question is, the hard gelatin capsule sizes are mentioned in their number. Their approximate capacity are listed in P2T, match their correct volume. So here you can see 0, 1, 3, 5. These are the numbers that they have given. And here you can see that ml is given. Here also 1 ml is there, okay, although you have only 4 options. So can you able to identify that which should be the answer for this one? Chalo, we'll solve them together. So in the class also I told 2-3 important things, right? Weight, so we have remembered with the tricks. So whenever it is 1, just divide it by 2. That is approximately it will be 0.5 ml, right? Then for 3 also, if it is 3, just write 0.3. So like that, if you remember at least these two, you can solve, right? So here you can see first is 0.55, 0.55, which is near to that 0.55. So here you can see first is S, right? Second is, you can see 0 is there, 1 is there, 3 is there, and 5 is there. As I told you, 3.3 you can remember, so this is R. So where you can see R, option B and option D, right? Either of them will be the right answer. Now first is, if you see option 0, so 0 is one of the largest, so 0.75. So T will be there and remaining is your Q. So 5 is 1.5. So sequence should be T, S, R and Q. So option D is the right answer. Many of you have solved also. Option D is the right answer. So little tricks you can remember, like 1 just divide by 2, so it will get 0.5. So this is like a volume and weight. Anyways, we have remembered in the weight. Okay. D is the right answer. Very good, all of you. Next question we will solve. The ratio of dry glycerin to dry gelatin for hard gelatin capsule. Remember, dry glycerin is nothing but your plasticizer. So if the value is higher, that means it is a soft gelatin. If the value is lower, it is a hard gelatin. So it is like 0.4, 0.6 and 0.8. So if it is 0.4, it is hard. If it is 0.6, it is medium. If it is 0.8, it is soft, because in 0.8, higher amount of plasticizer or glycerin is present. Now here they are asking for hard. Hard is what? 0.4 divided by 1. So the ratio is 0.4:1. Option B is the C won't be there because, see, C won't be there because if they ask you for the soft gelatin, then it will be 0.8. This is like for soft, this is for hard, and this is of the medium, because plasticizer or the glycerin increases the softness. So if you want hard, you have to keep it lesser. Okay, very good, all of you. This is the right one. The next question is, the most commonly used plasticizers in soft gelatin capsule shell are. Option A, sodium lauryl sulfate. It is not the plasticizer, rather it is a surfactant with HLB40, right? Glycerin and sorbitol is the right answer. Basically, they act as a plasticizer. They also act as humectant. Ethanol and methanol, they are solvent. Triazidine and diethyl phthalates are preservatives, so we will not add this. Basically, the plasticizers are glycerin and sorbitol. Apart from that, you can also add polyethylene glycols, that is nothing but macrogol, and propylene glycol. Okay, so option B, very good, all of you. Option B is the right answer. Option B is the right answer. Remember, apart from that also you have another certain kind of plasticizer. Chalo, next is, in the preparation of soft gelatin shells, the ratio of W/W of water to dry gelatin typically range between. Okay, so what should be the answer? There is a range for this and this. How much should be the water will be ranging to dry gelatin in case of soft gelatin? So 0.2 to 0.5 to 1, 0.7 to 1.3 to 1. This means that it is like 0.7 to 1.3 divided by 1. This is your water and this is your gelatin. This is the meaning of this, okay? Where your 1 is constant, you just have to see how the numerators are changing, okay? So option B, very good, all of you. Option B is the right answer. Where your water can range, the ratio can range from 0.7 to 1.3 and it will go up to 1. 1 is constant, that is dry gelatin. Chalo, very good, all of you. It is given in the 𝘂𝙾 book, you can see. Chalo, next is match the following steps. If you understand the steps of hard gelatin capsule, this is very easy, right? The first is dipping, spinning, drying and tripping, right? So the first is dipping. Why we do dipping? Dipping of what? The metal pins into the gelatin solution, which is held at 60 degrees Celsius. because to make sure that gelatin is present in the liquid form. So dipping is for the formation of capsule caps and bodies on the metal pin. So option A, column A is matching with first one. So A is the right answer. Right answer as in this is matching this one. Next is spinning. Why we do spinning? To have that uniform distribution along the pins, whatever your solution is there, so that a proper coating will be there. So spinning, second, again same one. Third is drying. Drying is what? Controlled removal of water from gelatin shell. Because it is a liquid, you have to dry it so that it will become as a solid. So 3 is there. Trimming. Trimming means what? Cutting. Because in this caps and bodies are forming, so you have to cut it and again join it, right? So trimming is nothing but cutting. So 1, 2, 3, 4, whatever sequence is given, that is the right answer. 1, 2, 3, 4. Very good. Option B is the right answer. No, how it will be option A? Option B, na, because the sequence is 1, 2, 3, 4. So it is 1, 2, 3, 4. Okay. So option B is the right answer. Chalo, very good all of you. You are able to solve this one. So this is a procedure: dipping, spinning, drying, stripping, trimming, joining and polishing. Next is the disintegration time for hard and soft gelatin capsule is. So what should be the answer? 30 minutes, 90, 15 and 60 they have given. So first is hard gelatin how much and soft gelatin how much? Everybody agrees? Because see, in soft gelatin higher amount of plasticizer is present, so it may take more time. So for soft gelatin it is 60 minutes and for hard gelatin it is 30 minutes. That is the ideal disintegration time. Please remember for this tablet also. I will just quickly tell you how to join the GDC weekly test. If you have not downloaded the GDC classes app, make sure you download the GDC classes app from the Play Store. Click on the batches section. Here at the corner you will see batches section, and then click on the plus icon where you have to enter your batch code. That is GDC quiz. There is no space in between. So GDC quiz, and then you can give your GDC weekly test as per the schedule. So do not miss the opportunity and make the most of it. Okay. Chalo, the next question is, the optimum moisture content of hard gelatin capsule shell ranges between, what should be the ideal moisture content for the hard gelatin? Can you tell me what should be the answer? 5 to 8% is very less. If moisture content is less, generally the shell becomes brittle and all, and if it is very high, there is no mechanical strength in them. So 12 to 15% is the right answer. Very good all of you. I can see Soparnika, Ankur, Devi, Deepika, Ishwar, Ratan. Very good all of you. Das, Urmila, Bhavesh. Very good all of you. Chalo, I know everyone has studied well. Option C is the right answer. Very good. The next is about match the following equipment with its application. So we have already seen there are so many equipments in the capsules. We have to see what should be the answer. Okay. Now one by one we will see. In most of them, by the name of the equipment only you can understand for what purpose it has been used. Okay. Say for example, roto-weigh. What is the use of roto-weigh? It is a weighing machine, right? So where it is a weighing machine? Capsule weighing machine. So first is C, right? First is C. Next is what? Vericap. Vericap, what we have seen, it is a sorting machine, right? Vericap we have seen it is a sorting machine. Next is what? Ecogel. Ecogel is for filling of powders, as we have seen. There is Ecogel, Ecofill and all, right? So where is the answer? Fills powdered dry solid into a soft gelatin capsule. Next is what? Sedinator PM60. Sedinator PM60. From P we have remembered it is a polishing machine. If you remember in the class we have seen it is a polishing machine. Next is what? Rotosort. Rotosort is a sorting machine. Some of them will be filled, unfilled capsule. So whichever is unfilled they will sort, right? So sorting of capsule based on weights. Fifth, only capsule sorting, because this is also sorting, na? So one is capsule, D it will be there because that is a capsule sorting. Next is what? Rotofill, right? Fill is what? Filling of the pellets. So what is the sequence? C, B, E, A, D and F. If you see, what should be the answer? Anybody who has solved? So Ratan, you are understanding or you are not understanding? So option 1 is the right answer. You can also tell the marks till then whoever got the highest. So please note it down if you are noting it down. But all the tricks we have earlier seen, right? Fill means filling of pellets, sort. But see, VeriCap is also there. Now this is a confusion. But they did not ask specific. So sort is your sorting machine, right? Apart from that, P is the polishing machine. We have remembered, if you remember, I have given the trick like from Prime Minister, like that we have created. Those who have attended the class, they will understand that, right? Next is weighing machine. We have already seen weighing means what? It is a weighing machine, right? In the industry, you will not weigh each and every capsule, right? Chalo. So are you understanding, everyone, till now what we have seen? So these are the machines. Please see whoever was present in the class. We have seen the tricks and mnemonics for this, how to remember. Okay, thank you so much. I'm glad that at least you are understanding here, because we really don't want language as a barrier. There are so many deserving students, but because of the language they are not able to understand. So definitely we'll try our best. Chalo, which additive in capsule shell provides opacity to protect light sensitive drugs? Wherever the opacifier will come, whether it is your tablet, whether it is your capsule, any dosage form, the classic example is your titanium dioxide. So opaque nature, when you want opaque nature, when you don't want the light to enter inside, right? That means you are creating a barrier. This is something, your material is present. You don't want light to enter into that because the material is light sensitive. So simply you will give the titanium dioxide coating, so to protect the light sensitive drugs. Colors also you can give, like umber and all, but that is for the suspension bottles or any kind of glass bottles you might have seen. But when it comes here, it is a titanium dioxide, okay? Whereas we will see why not another option, because see, lauryl sulfate is your surfactant that is having HLB of 40. Glycerin sorbitol are your plasticizer, not your opacifier. That is the reason option A, titanium dioxide, is the right answer. Next is, which of the following correctly represents the relationship for calculating minim per gram factor? Okay, so minim per gram factor is, you will mix certain kind of liquid and certain kind of solid and you will mix it together to give a capsulable mixture to fill into the hard gelatin capsule. So what is the formula for that? Based on this, there is one example also. I will tell you how to solve. It is very easy, but for that you should know what is the answer. Very good, Deepika. So this is minim. So minim is nothing but the unit for volume. Like 1 ml is equal to 0.06 ml. So this is nothing but minim per gram. Minim is nothing but volume for liquid. Gram is unit for solids. This is base adsorption, this is weight of a solid, this is volume, and this is weight of a mixture. So that is very easy. Here D represents density, but we do not take into consideration the density when you are calculating minim per gram factor. So option A is the right answer. We will see also like how to solve based on that. So see, this is a base adsorption, which is number of grams of liquid base required to produce a capsulatable mixture when it is mixed with 1 gram. So how much gram of liquid or how much minim of a liquid is required to mix with 1 gram. That is the reason it is coming minims per gram. That is minims of that liquid required for 1 gram. So it is weight of the base, weight of the solid. That is a base adsorption. BA we have written, na? So base adsorption is that. And then if you calculate further, minims per gram is equal to base adsorption plus S, that is the weight of a solid, into V, weight of a volume of a liquid, and W is the weight of a mixture, that is total liquid plus solid. We will solve this. Chalo, next, can you tell me what should be the answer for this? Which of the following treatment is used for the solubility of gelatin shell? Fumaric acid, formalin, sulfur dioxide or sorbitol? Just now we have seen to increase the acid solubility, to reduce the aldehydic tanning, we are using that. For that we are using fumaric acid, right? So just now in the previous question also we have seen, so that is a fumaric acid. But to increase the solubility or the treatment, which treatment is given? So fumaric acid already we have seen, sulfur dioxide, sorbitol is the plasticizer. So basically what we are adding is formalin, that is 40% formaldehyde, okay. So 40% formaldehyde, that is retard the dissolution of the gelatin shell. Remember the composition, formaldehyde not entirely 100%, 40% is nothing but the formalin. Next is, in the formulation of suspension of soft gelatin encapsulation, base adsorption of the solid to be suspended. Now they are asking the number of grams of liquid base required to produce a capsulable mixture when it is mixed with 1 gram of solid. Can you tell me base adsorption? I have shown you the formula. What should be the answer for this? We'll see. First of all, we'll rule out the options. Number of ml. Just now I told you it is not about the number of ml, right? Or number of mg is also not there. We have seen. So either it has to be A or C. So A is number of grams of liquid base required to produce a capsulable mixture when it is mixed with 1 gram. Yes, that is the right. We will see why not C. The number of grams of solid base required to produce a capsulable mixture when it is mixed with 1 gram of the solid. Either this has to be there or this has the number of grams of, here it is not a solid, we are mixing liquid, right? Number of grams of liquid for 1 gram of the solid, right? But in the option C they are telling number of grams of solid required to mix with the solid. We are not mixing solid with the solid, we are mixing liquid with a solid, okay? So that is the reason option B, C and D will not be there. Option A is the right answer. Very good, option A is the right answer. That is your base adsorption. So base adsorption, weight of the base is your liquid and weight of the solid. Chalo, if 1 gram of solid drug requires 0.8 gram of liquid base to form a capsulable mixture, then the base adsorption factor is. So just now we have seen base adsorption factor is what? How much gram of liquid base is required for 1 gram, right? So in that how much it is given? 0.80. To produce what? How much? 1. So simply base adsorption factor will be 0.8 because you are mixing 0.8 gram of liquid to get 1 gram of the capsulable mixture. So simply 0.8 divided by 1, it will be 0.8. Option B is the right answer. In Hindi, we already have Hindi batch, and this is GDC English because there are some students who do not understand Hindi. So for that reason, we cannot tell in Hindi. Okay, we have one more channel, right? GDC Hindi, but here it is GDC English. We want everyone to understand whatever we are teaching, because ultimately you will be giving in English language. That is the reason, because we don't want a barrier for that, like a language as a barrier. Okay, so that is the reason on this channel specifically we are speaking only in English. Okay, chalo, option B is the right answer. You understood that weight of liquid directly given, base is nothing but liquid, do not get confused. When you will mix together, it will form a capsulable mixture, but before that it is a liquid and a solid. Yeah, okay, fine, I'm continuing in English, don't worry. So 0.8 divided by 1, directly it was given. Chalo, now which of the following methods involve the use of 𝑙𝑒𝑥𝑎 quota for dust removal and polishing of hard gelatin capsule? So even though you are filling it with a machine, there are chances that some material may be present outside the capsule shell also, or on the capsule shell, right? So you use certain kind of equipments to make sure that it is polished properly. 𝙂𝙀𝘾𝙀𝙎 is one of the method. So which of the following method involves cloth dusting, pan polishing, brushing method, air jet cleaning? Option B, very good, is the right answer. Yeah, I will come to that point, Abhishek. Even I got thing. I think that fumaric acid should be there, but they are asking it. I'll come to that point again after the class. I'll come to that point. Pan polishing, 𝙂𝙀𝘾𝙀𝙎, we have seen. That is a very direct question. Please, these equipments are very important, because in tablet you don't have such equipments, right? So the question from this, it is very important from the capsule. So this is one of the questions that they have given. We'll solve it together. So calculate the, I'll give you like a minute to solve, but I'll just tell you what is given. Calculate the minims per gram. So minims per gram you have to calculate for a preparation of a capsule in which the base amount is 1, solid amount S is equal to 2, volume is equal to 16, and the weight is equal to 2 grams. Can you solve this? Everything is given, you just have to put it into the formula. If you want, I'll give you the formula also. Like this is the same formula that we have seen earlier, just a rearrangement will be there, okay? So everything is given, you have to calculate the whole minims per gram. Base adsorption is given, S is given, W is given, and V is given. Can you solve this? 28. I think you have solved. A is the right answer. Very good, all of you. 24 minim gram. See, you just have to put what is BA 1 plus S is 2, right? Divided by W is 2, and then 16. 8, it will be 3 into 8. 24, right? So very easy. Sometimes like this question only, even you will not even require your calculators and all, okay? So option A is the right answer. Understood this? Say for example, if they have not given base adsorption, then you first calculate base adsorption by calculating amount of liquid divided by the grams of solid, okay? That will be the additional step if BA is not given, base amount is not given. But for this, option A is the right answer, okay? BA plus S into V divided by W. Very good, all of you. A is the right answer. For capsule with average weight more than 300 mg, the maximum allowable deviation is, whether it is your tablet, whether it is your capsule, I always tell that higher the weight, lesser is the deviation. Whether it is tablet, whether it is capsule. As you increase the weight of the tablet or the capsule, the deviation keeps decreasing. And the deviation is 3 only, 100, 7.5 and 5. So in the capsule, you tell what should be the answer. B, very good, 29th, B is the right answer, 7.5. When your capsule weight is more than 300 mg. If it is less than 300 mg, it should be 10%. 15 and 5% in the capsule, it is not there, okay? So very good, 29th, B is the right answer. Ratan, you can talk with the ma'am, like who has done your admission, and then you can let us know, okay? Like maybe there can be a procedure. So average weight, total number of, this is a uniformity way of weight, and now I am not going to explain, we have seen in the class. You will take the weight of the capsule, then check it is matching or not. And sometimes if it is a hard gelatin capsule, you will open the capsule and then take the weight of inside material. That inside material is nothing but the net weight. That you will do if your test is failing, okay? So that is anyways another thing. Chalo. In the uniformity weight test for capsule, how many capsules are weighed individually and what are the permissible limit deviation for different capsule weight? So just now we have seen what should be the answer. Chalo, we'll see. First of all, how many capsules you will see? You will take 30, initially us say 10 and 20, right? But in the uniformity, that is a content uniformity. But for the uniformity of the capsule, you will take how much capsule? 20 capsule. 10 is definitely not there, okay? You don't even have to see whatever is given afterwards. That will save your time, okay? So 10, 30 cancel. Now see 20 capsule you will see 300 mg plus minus 7.5% plus minus 10% if it is more than 300 mg. This is exactly opposite. If that is the reason I give you the tricks, because in these things you may get confused. Lesser the weight, higher is the deviation. Higher the weight, lesser is the deviation. Okay. So that is the reason option C is the right answer. Very good all of you. I can see you have solved. Very good. Option C is the right answer. By the way, you guys did not tell what are your scores and all. Nobody is going to judge you. At least you can let us know what are your scores. So this is the procedure. You will take the weight of the capsule and take the average weight of the capsule, compare the average weight with the individual. Chalo, which of the following combination correctly matches the type of capsule filling method with its machine and material handled? Auger type 𝘿𝙎𝙎𝙎 and McOphar powders and pellets. Dosator type 𝘖𝙎 that is a powder, paste and small capsule. Vibratal fill Perry and Osaka granules. Ecofill, rotofill, Osaka powders and pellets. See, now here I cannot tell because it is shifted, but we have already seen peri from the fries and all. These are the tricks if you remember in the class, those who were present. So B is the right answer, that is a dosator type. 𝘖𝙎 is the dosator type. We have seen so Pharmatic and McOphar Mg2 𝘖𝙎 because this is the last letter of the alphabet. It contains all the materials. I told you powder, pellets, paste, liquid, everything will be present in the 𝘖𝙎. So like that, some tricks we have already seen in the class. These are Hindi, so I will not explain this one now. Chalo, the defect star end in capsule shell occurs due to, we have seen if star like some structure, if it is there, why it happens? Option A is air bubbles during gelatin dipping, uneven distribution or excess gelatin on the end of dip coated pins, low bloom strength gelatin, high drying temperature. Why it happens? Because definitely there is uneven distribution or excess gelatin on the end of the dip coated pins. That is the reason you do spinning technique, right? Spinning will make sure that there is not accumulation at the one end of the capsule which gives the star end. So if you spin it properly, make sure that there is an even distribution, then star ends will not happen, okay? So uneven distribution, very good all of you. Option B is the right answer. Option B is the right answer. So these are the some kind of defects that if you read you can understand very easy, twinning and all. Next is ingredients used for capsulation in some capsule should flow by gravity at a temperature not exceeding dash. So whatever ingredients you are using for capsulation in the soft gelatin capsule should flow by gravity at a temperature which should not exceed by how much? 35, 30, 25 or 20. So it is little bit higher than room temperature, that is your 35, or close to a body temperature you can say, that is your 35 degrees Celsius, okay. So it should not flow, it should flow by gravity at temperature which is not more than 35 degrees Celsius, okay. The moisture content I think everybody knows. So the next question is, rotosalt can handle capsules per hour. Now this is very direct questions, like for every instrument there is certain kind of limit that rotosalt can handle this equipment can handle this. So rotosalt is a sorting machine, as we have seen. If the weight of the capsule, say for example one capsule is having a weight of 250 mg, then you will set a limit. For example, you set the limit between 230 to 280 or 270. Then if the capsule weight is 220 mg, this will be directly sorted, and whatever this range capsules are there, that only it will take, right? So option C is the right answer. Very good all of you. Option C is the 1,50,000 per hour. That much capsule it can handle. Chalo, 𝘎𝙂𝘾𝙎𝙎 is used as a capsule manufacturing. Which machine is there, 𝘎𝙂𝘾𝙎𝙎? Dedusting and polishing, finishing of filled gelatin capsule, filled capsule sorting machine, high speed capsule weighing machine. These are not there. Field if it is there, it will come field. But this PM, 𝘎𝙂𝘾𝙎𝙎, if you remember those who were there for the previous class, so we have remembered PM as a prime minister, like that some we have remembered, Kia from the Kia, the vehicle which is there, and the polishing. Okay, so it is a dedusting and the polishing machine. With due respect to everyone, it is a polishing machine. Okay. Next is in hard gelatin capsule, the approximate capacity in mg of capsule number 4 is. So again, if you remember that trick that you have to subtract this and that. So capsule 4 where you will subtract 50, so it will be 150 mg. So I'll just tell you again. You just start, largest is 950. Then you have to subtract sequentially. For example, initially you will subtract 300, 200, 150, and then you have to subtract 50, 50. It is very easy, like less than 30 seconds it will take, right? So for the capsule 4 it is 150 mg. Or you can also start from 100 and then keep adding this, whichever is easy for you. You can start like this or you can reverse it, but instead of subtracting you have to keep adding. Okay, so whichever is easy you can solve that one. Chalo, the moisture content of capsule shell is determined by. Can you tell me what should be the answer? The moisture content of capsule shell. Definitely there is a limit. How will you determine? IR spectroscopy will not tell you about the capsule shell. Basically this method is to study the functional group, if there is a change from crystalline to amorphous and all. Echo gel, and just now we have seen 𝘎𝙂𝘾𝙎𝙎 is not there. But Tolwyn distillation method is to check the moisture content of the capsule shell. Okay. If you want to check moisture content in any of the sample, then you also have the Karl-Fischer titration. I think you guys know that from the analytical point of view. I'm just telling that. Chalo, the next is in capsule manufacturing, EDTA is used as. Wherever EDTA is used, the only purpose of EDTA, that is ethylene diamine tetraacetic acid. Remember the valency is 6 because ethylene diamine. Di means 2, tetra means 4. So it becomes 6. Just for your information. Okay. So it is a chelating agent to prevent oxidative decoloration. That means it will form a complex, it will form a chelate and it will produce the oxidative discoloration. Very good, all of you. B is the right answer. Next is in capsule formulation, which substance is added to reduce the dusting and enhance powder cohesiveness during filling? Alcohol, organic solvents, inert, edible FDA approved oil, or strong acids? First of all, strong acid, why we will add? The solvents, and alcohol is nothing but solvents only. So these are the things which we will not add. But if to improve the cohesiveness, enhance the powder cohesiveness, we will add certain kind of inert, means which will not be reactive, which will be edible, and which are approved by FDA. So we will add option C, right? Very good, all of you. Option C. No, Bhavesh, organic solvent, why we will add? If you add any kind of solvents, that will not reduce the dedusting, right? So certain kind of oils, because you know oils are adsorbent also. So that is the reason. Okay. Chalo, very good, very good. You know the answers, but sometimes it may happen that when you see the option, you feel that, okay, this can also be there. Okay. The control soft gelatin capsule is dried to equilibrium with relative humidity of how much? So you are, because soft gelatin capsule is containing higher percentage of plasticizer. So it has the tendency to absorb moisture to some extent. So there has to be a controlled humidity. How much should be the humidity? So as you see, if it is 60 to 80, that is almost accelerated one, right? So 20 to 30%, which is a normal room temperature. So B is the right answer. Okay. 20 to 30% relative humidity and 21 to 24. Please understand, whenever they are telling control, that means the room temperature conditions they will ask. This whatever 40, 50 you are saying, that is the accelerated one, that is a higher conditions will be there. Okay, so 20 to 30% relative humidity is the right answer. Now you have to match. These are the microencapsulation technique. Depending upon the technique, you have the specification for that technique. So you have to match the column 1 with column 2. Now let's see air suspensions. So air suspension method, where the air particles will be there, that is for the solids. So it will have a core material 35 to 5000. So basically there is a core material which is to be coated. It can be drug particle, it can be granules or something, and there will be a coating material. So many reasons are there why we go for this one, like if you want control release, if you want to protect the drug and so on. So air suspension, it is for the solids only, 35 to 5000. Okay. Next is coacervation phase separation. Are you also solving? I can see. I will come to that point, Abhishek. I told you I have seen your question. After we complete this 9 more question, I'll come to that point. Okay, please let me know if you are solving this one, or shall I solve? Chalo. So air suspension we have seen, that is 3 solids only, right? Next is coacervation phase separation. Remember, coacervation phase separation we can use for solids as well as liquids, and the size is 2 to 5000. Okay, so this is 3, this is 1. Then we have pan coating, that is only for the solid. Higher particle size is there because that is a pan coating. So second, and next is what your solvent evaporation. So that is 5 to 5000. So 3214, very good all of you. Option B is the right answer. Okay. Next is a water soluble substance used as a coating material in microencapsulation process is. Water soluble material they are asking. Okay, water soluble material used as a coating material. See, polyethylene is also water soluble, but we are not using it in the coating material, right? Silicon, paraffin, these are not there. We are not using. Hydroxyethyl cellulose or hydroxypropyl cellulose, because these are the polymers, they have the ability to retard the release, or they have the ability to give the protein coating to that particular material. So we are using hydroxyethyl cellulose. Very good. C is the option, right answer. Very good all of you. So see, water soluble resins are there, water insoluble is also there, enteric and waxes are also there. But if they ask you water soluble, then they are the cellulose derivatives. Very good, C is the right answer. Next is, which of the following correctly represents the sequence of the steps in coacervation phase separation? So what should be the steps for this? First is coacervation phase separation. You have to first form the phase, right? So phase formation will be there. Then the deposition. Deposition means the liquid phase which has been formed, that has to be deposited on the solid layer, which is nothing but your coating core material. So liquid phase is your coating material, your solid is your core material. This coating material will be uniform into the core material, and it gives rigidity to that droplet or to that particle. Very good all of you. Option B is the right answer. Very good. So see, there are 3 steps. Formation of 3 immiscible phases will be there. Then the deposition of liquid. This liquid is your coating material, which will be deposited on the solid material, which is your core material. Okay. So very good. Deposition will be there, and then rigidization. In microencapsulation, the method in which the core is dispersed in a polymer solution and dried by hot air is called as dash, whereas the method where core is dispersed in a molten as in melted, melted coating and then solidified by cool air is known as what? See, whenever here they are using a cool method. The method is same in microencapsulation. The only thing is that whenever you are using a cool air, that is nothing but spray congealing. That is nothing but the spray congealing. Whereas whenever you are using hot air, it is nothing but spray drying. Okay. The only difference between them is spray drying and spray congealing. Why? Because in the spray drying, there are some material which cannot withstand that much temperature of the hot air. Maybe they are undergoing certain kind of you say degradation or something, in that case you can use a cool air, that is your spray congealing. Okay, so because here they are telling hot air, so that is first part answer is spray drying, second cool air is the spray congealing. Okay, chalo, very good all of you. The liquid fill capacity of a capsule should not exceed dash of the capsule body volume to prevent the spillage. Definitely, if you fill the bottle at the end maximum capacity, then there are chances that it may get spilled off, right? So same thing happens in the liquid fill capacity of a capsule. So how much should be the maximum value such that it will not spill? Very good Abhishek, very good Devi. The C should be there, 90%, because 10% sometimes, not here, sometimes whenever you see any of the filling volume, the empty space is known as head space. Okay, so that is required specifically in the centrifuge tubes if you are using. So this is the head space that we maintain. Chalo, which of the following combination is correctly matched? Color pigment ethyl vanillin, flavor titanium dioxide, anti-caking agent silicon dioxide, buffer PEG 400. What should be the correct one? Ethyl vanillin is the flavor, not the color. Titanium dioxide is a flavor? No, right? C is the right answer because that is a anti-caking agent which will make sure that it will not form any kind of lumps. PEG 400 is your plasticizer, not your buffer. Okay. Very good, all of you. C is the right answer. I can see anti-caking agent. Okay. So these are some of the excipients. You can go through it. Okay, chalo. Next is sulfur dioxide is used in the manufacturing of hard gelatin capsule to impart the strength to the capsule, improve flexibility, opacify the shell, prevent the decomposition. It will not impart strength, right? The strength is given by use of plasticizer. Improve flexibility, no, that is same again. Plasticizers will give. Opacify, titanium dioxide. It will prevent the decomposition. So it will prevent the decomposition. So here some question was there, right? So basically used to prevent the decomposition, retard dissolution of gelatin shell. I will come to that point. Fumaric acid increases the acid solubility, but there they did not mention it is acid solubility or what. Directly they mentioned the dissolution. So anyways, formalin should be the right answer. I think this is the same explanation that was there for that question. So you can just make a note of it. Fumaric acid increase the acid solubility, increase the acid solubility, right? For example, if the drug is going into the stomach, which is acidic, and reduce the aldehydic tannin, and formaldehyde retard the dissolution of the gelatin. So you please make a note of this. This is the same explanation for that. I think Abhishek was asking. I hope Abhishek you are there. Which of the following correctly relates Bloom strength and the molecular weight of the gelatin? That means Bloom strength is directly proportional to the molecular weight, inversely proportional to the molecular weight, square directly proportional to the square, or inversely proportional to the square. Yeah, it will retard. They are asking increase. I will see that question again. Wait. So it is directly proportional, as I told you. Higher the molecular weight of the gelatin, higher will be the gelatin molecules will be present, more cross-linking will be there. So you will require higher amount to make sure that the plastic plunger will go deep inside. So very good, option A is the right answer. Next is ICH, accelerated storage condition of capsule testing are. So accelerated means, see, sometimes the name itself is sufficient. Accelerated means little bit higher temperature and higher relative humidity is present. So how much should be present? So it is 45 degrees Celsius and 75% relative. No, not 37. 37 is your body temperature. Always remember, whenever it is higher, little bit higher, it is 45 degrees Celsius and 70. But general for tablet, it will be 40 degrees Celsius. Okay, it is 40 degrees Celsius. It should be 40 degrees Celsius. Make a note of it. 37, it won't be there. Okay, make a note of it. 40 degrees Celsius, and generally for tablets, but for capsule it will be 45. So in the Lachman also it is given specifically for the capsule, gelatin capsule. Normal tablet is 40 degrees Celsius, but the capsule is 45 degrees Celsius, 75% relative humidity. Chalo, next is temperature of gelatin solution during dipping is how much? 20 degrees Celsius, 10 degree, 15 and 5. Dipping means, as I told you, temperature of gelatin they are asking, not the temperature of the pins. If they ask you temperature of the pins, that is 22 degrees Celsius. If they ask you temperature of the gelatin solution, that is 50 degrees Celsius. Because at this temperature only it will be liquid, otherwise it will become solid, right? So that was all about your 50 questions. I'll just get back to that question. See, which of the following treatment is used for the solubility of the gelatin shell to retard the gelatin? I'm not getting why there is still confusion. So to decrease the or to retard the solubility, which of the following treatment is used for the solubility? The question is incomplete. Here there should be a question that to retard the solubility or to retard the dissolution. They did not mention is used for the solubility. So basically here there will be one word, that is to retard the solubility. Then formalin is the right answer. Retard the dissolution. Okay, here one word is missing. That is the reason even I got confused when you asked. Okay, so to retard, one word is missing, to retard the solubility, because they did not mention. If they mention to increase the acid solubility, then definitely your fumaric acid, as we have discussed, will be the right answer. So I hope, not like answer is not like wrong, we can tell that here one word has to be there, that is a retard. Which of the following is to retard the dissolution? But since they did not mention it as increase or decrease, we can select any of them, right? But here the word has to be there to retard the solubility or to retard the dissolution. Then we can say that it is a formalin. Okay, but to increase the solubility, as I think Abhishek said, fumaric acid will be there, that reduce aldehydic tanning and increase the acid solubility. So I hope till here it is clear to all of you, and you have understood all the questions that were asked. I think there were, except few questions, all the questions we have discussed in the class. So please make sure go through the syllabus very well, and all the very best for your preparation. Okay, Abhishek, I think now you are clear. Even I got confused like when you asked that. But I hope till here it is clear and you have understood all the questions and their explanation. So all the very best for your next GDC weekly test. And if you have not downloaded the GDC classes app, make sure you download the GDC classes app and subscribe to our YouTube channel, which is GDC Classes English. Thank you so much all of you for your response. See you all in the next class.